Okay, so prove true for n equals 1. So that's 1 times 1 plus 1, 1 plus 2. So there's 1 times 2 times 3, which is 6, which is divisible by 6. So assume true for n equals k. That means k plus 1, k plus 2 will equal 6m, where m is an integer. And then prove for n equals k plus 1. So required to prove that k plus 1, k plus 1 plus 1, k plus 1 plus 2, which is k plus 1, k plus 2, k plus 3, is divisible by 6. Okay, so proof. So if we take the assumption, which is n equal k, you have k plus 1, k plus 2 equals 6m. Now, if I look at that, the thing that's common there is the k plus 1. So if now this one has like a little trick to it. Because if you start with this, look at k plus 1, k plus 2, k plus 3, and you expand the brackets of this one, and you get k plus 1, k plus 2, plus. Okay, so they expand that when you get that, and then the common factor is k plus 1, so this here is equal to 6m, which is divisible by 6. Now this one here, you've got the 3 there. Alright, so is this divisible by 2? Okay, and it's probably going a little bit out of the 3-note syllabus and creeping into 2-note. But if k is odd, then k plus 1 is even, isn't it? So if it's even, it'd be divisible by 2. That's one option. If k is even, that means that if k was even, that means that k plus 1 is odd, and that would also mean that k plus 2 would be even. So that means that this part here would be divisible by 2. Therefore, the whole thing would be divisible by 6. So therefore, that's divisible by 6, and that would be divisible by 6. Because whether k is odd or even, this here would be, one of those numbers would be even. So therefore, this is true. If you assume true for n equals k, then it's true for n equals k plus 1. And that's by the process of mathematical induction.